Today we will talk about one of the most important subjects related to the operation of amine regeneration unit. As we know, the amine regeneration unit is common unit in refinery or even in the gas plant. So if you are working in natural gas processing sector or in refinery, you will work for sure with the amine regeneration unit. For this, you need to know the source of trouble and how to overcome those trouble. Simply, the first subject we will talk about poor regeneration or high H2S in lean amine. High H2S in lean amine, this means that you did not make a good stripping in this tower. This is a stripper and this is the rich amine treating by this reboiler. Okay, so you add steam here to reach to specification specified related to the amine, which is ppm of H2S in the lean amine, maybe lower than 900 or between 900 500 ppm H2S in the lean amine here. Okay, so what will happen? Lead to poor regeneration. What happened? Lead to high H2S in lean amine. The symptoms first from the laboratory, you will find high concentration of H2S in the lean amine, high lean amine loading or downstream corrosion. This may be happen due to low reboiler duty because there is a ratio here between the flow of the amine or the load of the unit and the processed steam to the reboiler. This you have to keep this ratio all time in the operational margin. If you are lower than this specified ratio, the steam will not be enough at this reboiler and you will get high concentration of H2S in the lean amine. High H2S in the lean amine. Okay, and maybe foaming happen lead to high H2S in the lean amine, excess circulation or the composition of heat stable salt. What he mean by excess circulation? In the amine unit, there is a design flow for each amine unit, like for example 200 cubic meter per hour. If you increased this flow more than the design, so he means by over circulation. So whatever the steam you introduce to the reboiler, you are already over the design. Okay, so what is the clear result? That you will get high H2S in the lean amine. So to cure this problem, to adjust this situation, you have to increase the reboiler steam, clean the reboiler in the nearest shutdown, control your foam by injecting foam for half an hour, optimize the circulation, don't go more than the design flow, and reclaim the amine. Okay, this is the suggestions to clear this situation. So you take it step by step. First step is to adjust the steam ratio and send lab result to laboratory. Okay, so you adjust it. Okay, and go step by step through the slide. One of the most famous problem in the amine regeneration unit is foaming in regenerator. Here the level fluctuation, amine carry over with the gas, poor acid gas quality, high delta B through the tower, high delta B through this A tower, because this tower working with BDI give you indication and action on the steam going to this reboiler. Okay, so high delta B at this tower and high delta B at this tower, one of the indication for the foaming. Okay, amine carryover, level fluctuation, and higher delta B at the tower indicate some foaming at the tower. Foaming is the common problem related to amine regeneration unit. What is the possible causes? Is hydrocarbon contamination, solid and corrosion product, excess anti-foam, because the anti-foam injection should be stabilized and operated at specified time. Okay, if you increase this injection time, which means that you dose more from the anti-foam can make the reverse action. In spite to inhibit foaming, it will promote the foaming on the surface of the tray. So you have to be careful when you use the anti-foam injection. How to solve this problem? Improve the filtration, skim the hydrocarbon, and optimize the anti-foam injection. Okay. High reboiler steam consumption. High reboiler steam consumption, the symptom is steam use above the design. This is a symptom, okay? What are the causes? A high circulation rate. You are working more the design flow related to this unit. Insufficient stripping, okay? Because the rich load more than the design. This means that when you receive the rich amine, which carry over inside more H2S and more sulfur, you have to look and make comparison between rich amine load coming to the unit and the design, because each unit work with a specified design, not for granted. Okay, so when you make this comparison, be sure that your rich amine is not loaded more than the design. Okay, fouled tray or packing. Here the remedy is to reduce the circulation or inspect the internal nearest shutdown, check the amine concentration. Okay, reboiler fouling. The symptom is high steam flow because you inject steam, you introduce more flow of steam to the reboiler, but no efficiency. I did not get increase in the heat. Low heat transfer. The causes is iron sulfide. The composition between iron, which is result from the corrosion, and the sulfur, iron sulfide, okay, can make fouling for the reboiler and inhibit little bit the efficiency of heat transfer. Amine degradation also can cause to reboiler fouling and decomposition of heat stable salt, and we will describe the maximum concentration from each of those components at the end of this lecture. The action or the remedy is to chemical cleaning, improve the filtration for sure, because you have a side stream carbon filter. This can remove all this or help remove all this, and oxygen control, especially during startup. Okay, especially during startup. Reboiler tube corrosion. This happen because of oxygen ingress, high temperature, high heat stable salt. Okay, so what he mean by oxygen ingress? He mean that before you start up this unit, you have to make inerting to the unit by purge the unit 3 times by nitrogen and take sample, and don't work with the unit more than 0.2 volume percent O2. If you neglect this step, there is some oxygen ingress because you shut down for maintenance, some oxygen introduced. This can lead to tube corrosion, okay? And the action is control the temperature, remove the oxygen source, okay? And use corrosion inhibitor to control this process. And I want to inform you about the reboiler. There is some behavior to the reboiler related to the reboiler, which is reboiler leaking. Why from time to time you find reboiler leaking? Because during the startup also we mentioned the air ingress and how to solve this problem. The other side, we need to discuss the ramp of increasing the temperature during the startup, because you have to take it slowly. You have to take it step by step, maybe 15 degrees C per hour. Why? Not to break the gasket at the reboiler and lead to steam leaking or something like that. This is another problem related to the reboiler during startup. Be careful from an O2 ingress and the reboiler leaking. High regenerator pressure. Poor stripping efficiency, increase in the reboiler duty. Okay, this is the symptoms. The cause can be the condenser, overhead condenser fouling. He did not condense efficiently. Acid gas line restriction, because there is some scales or something like that make narrowing for the for diameter of this line and make high regenerator pressure increase. High reflux drum level. This is very critical. Okay, so the action or the remedy is to clean the condenser, check the acid gas line, and to control the drum level. Okay, here this is the condenser. if there is a narrowing in the tube, mean that the diameter of each tube decreased by the time by there is a promotion for some scales as a result of the corrosion or something like that. If you have higher liquid here, all this can resist the pressure control and you will find high pressure at your system. Excessive amine losses, maybe by carryover or something like that. This is high makeup. How you remark excessive amine losses? Daily you should take the concentration of the amine. Okay, if you are working with DEA, diethanolamine, you are working with concentration 25%. So if this concentration decreased and you start to add some water, this means that you lose the level from your unit by evaporation or by losses to flare or from PSV. There is a many tools can lead to this excessive amine losses, like PSV passing, like you add more water to the system, like there is some knockout drum remove a huge amount of amine with, like there is a carryover with acid gas itself from the system. Okay, all this causes foaming, high vapor velocity, mist eliminator as he mentioned in the slide. All this can lead to excessive amine losses. How you can control the foaming, check the vapor load and maintain mist eliminator in its position or check. Okay, here high lean amine temperature. High lean amine temperature, so the symptom is reduce the absorption efficiency and increase the corrosion. The causes is exchanger fouling at the outlet of the unit and the poor cooling and excess reboiler duty. The action here is to clean the exchanger to improve the cooling and optimize the heat input. Acid gas quality problem, yes, because when you make regeneration to the amine unit, you will get some acid gas going to the sulfur production plant, and there is a quality for this acid gas. This quality can go in the wrong side. Okay, why? Because poor of the regeneration, because of excess reflux, because of foaming, and the action will be improve the stripping, okay, by adjusting the steam ratio and optimize the reflux, and there is a ratio for the reflux also, okay, and eliminate foaming by injecting anti-foam. Okay, the typical normal operating target here for the reboiler temperature are from 120 degrees C to 130 degrees C. Lean amine loading between 0.1 to 0.2 mole for each mole amine, and the regenerator pressure normally to be around 1.5 in measure of units in gas plant or in a refinery, the measure, okay? And the amine concentration for methyl diethanolamine between 40% to 50%, diethanolamine between 25 to 35, and monoethanolamine it is around 20%, okay? So the golden rule for stable operation in amine unit is to control your contamination and keep the amine concentration. Avoid over circulation, be away from over design flow. Keep the oxygen out, especially during startup. Maintain the filtration efficiency and reclaiming if you have reclaiming system. Stay within thermal limits, okay, which is the design value related to the amine unit operation. Okay. Finally, I want to give you some guides for the heat stable salt, for example. What is the margin? If you are more than 3 weight percent, you are critical. If you are between 1.5 3 weight percent, it's acceptable, but better to be lower than 1.5 weight percent heat stable salt. High heat stable salt cause poor regeneration, high reboiler duty, and severe corrosion. Okay, the total dissolved solid, TDS. It will be good if you are lower than 3000 ppm, acceptable between 3000 and 5000 ppm, critical if you go more than 5000 ppm. High TDS lead to foaming, fouled exchangers, poor stripping efficiency. Okay, you have to keep that in your mind all time. dissolved iron, which is very critical, okay? It will be good and accepted if the dissolved iron lower than 5 ppm, and it will be accepted if you are in the range between 5 and 10 ppm. Critical if you go more than 10 ppm. High iron indicate active corrosion in your unit, iron sulfide fouling, and high foaming tendency. Look to the amine concentration as we mentioned before, and we mentioned what having can lead to loss in the concentration of the amine, like degradation, like passing from PSCV, like skipping or carry over with the acid gas. Many items can lead to loss of the concentration. Lean amine acid gas loading is lean amine acid gas, which means that when you produce lean amine, okay, there is a load related to H2S or sulfur component. It will be between 0.1 0.2 mole acid gas per H mole amine. If you are more than 0.25, you are higher, okay? You have to increase the steam ratio to adjust the lean amine loading, okay? High lean amine loading, poor regeneration for sure, okay? And finally, the pH in the amine unit or in the lean amine, especially between 9.5 to 11. Lower pH lower than 9 indicate high heat stable salt in your system. For check with sample high heat stable salt in your system, okay, and degradation. Suspended solid should be lower than 5 ppm. It will be critical if you go more than 10 ppm. Okay, the solid cause foaming, plugging, tray backing, fouling. Okay, so the suspended solid is very critical also. Hydrocarbon, especially during startup, okay, should be nil. Okay, and its persons indicate foaming and absorber efficiency loss. So this is the main general troubleshooting related to amine unit operation. And finally, I want to thank you all, and as we used to say, appreciate it.